So in this section for the AMAT trigo, we are dealing with the double angle formula. So I will say the double angle is one of the harder formula. Okay, so I'm going to show you how is it being shown to you during O level first. So in O level, right, it's portrayed to you in this format. So if you take a look, right, okay, the double angle is actually here. So there will be one double angle. They will give you the sine 2a equal to 2 sine a cosine a. So then the tricky ones will be on cosine 2a. Cosine 2a got three formulas. So there are three equivalent formula. So this is the troublemaker. So when there are three formulas, sometimes you need to choose correctly. So for cosine 2a, there are three formulas. So but they put it in this way. Tangent 2a, there's only one formula. Okay, so the like I said, the troublesome part is cosine 2a because there are three of them. Okay, so in the O level format, they give you sine 2a, they give you cosine 2a, they give you tangent 2a, but you must be able to write double angle into like sine 4a, cosine 4a, or tangent 4a. So you must understand the logic of double angle. Okay, so just to show you first, this is how the O level will be given, will show you the double angle formula. So your job is to be able to twist the double angle. So what do I mean by twist the double angle? So for example, okay, why is the name double angle? So the angles on the left will be always twice the angle on the right. So that means that, right, I can write a sine 4x and I will get a 2 sine 2x and cosine 2x. I didn't change the coefficient. The coefficient 2 is still the same. Okay, so you must be able to relate. You must be able to see that the angle is double up. Okay, the angle on the left is like 2 units. The angle on the right is 1 unit. So similarly, of course, if you need to, you can write as sine 6x. So the coefficient still doesn't change. You only change the angle. So that is the special thing about double angle. Okay, so it doesn't apply to any other formula. It's only on this part. So one of the more critical ones sometimes is to write it as sine x. Sine x, then you got something like this. Okay, so you need to understand sine 2x. And then from sine 2x, you should be able to write down sine 4x, sine 6x, and sine x. Okay, here comes the troublemaker part. The troublemaker part is on cosine 2x. There are three of them. So meaning, if I'm going to be writing like cosine 4x, I should also have three formula. So the angles on the left, can you see 4x? That's like 2 units. Okay, so the angles on the right become 2x. So I can write in this format as well. Okay, when I write in this format, I don't change the coefficient. The coefficient 2 is still the same, and I'm still subtracting 1. I'm only changing the angle. So cosine 4x. So the 1 is still there, minus 2 is still there. I'm only changing the angle. So that's one difficult part that you actually need to relate to double angle if you didn't know about this trick. Okay, so that means one of the more important one is actually this. It's actually the one that I can write a cosine x. So I can write a cosine x in this format. Okay, so these two you need to outline, you need to put a star for yourself. It will be used in some difficult question. Okay, so these two will be used in some difficult question. And these two is not going to be given to you. You need to be able to relate these two from the O-level given formula. So same for tangent 2x. So if they gave me tangent 2x, I'm supposed to be able to write tangent 4x. I'm not changing the coefficient 2. I'm only changing the angle. So similarly, I can also be writing tangent x. So this one is also important. You will be using in some difficult question. So the 2-star formula are not provided in the O-level, but you need to use what is provided in the O-level to come up with the two important blocks of formula. So that is one difficult part on double angle. So in example 1, let's just try to get used to the double angle formula. So this look like the one for sine. So it should be 5 times 2. So that should be a sine 50. So this is the one on cosine. So it should be 54. Obviously, this is the one on tangent. So that's how I get my tangent 70. Okay, this is the one on cosine. So it helps, of course, if you can remember all the formula in your head. So this is the one on cosine. And in the double angle, sometimes you end up using addition formula. And then and of course, the triangle methods, drawing triangle is the same thing. And solving also. But all these are slightly more difficult than addition formula because double angle is a set of formula that confuse most people. Okay, so with the idea here, I'm going to introduce the drawing again, then before we talk about more stuff. So in this case, again, we're going to think about the quadrant. So this will be sign positive. It can be first or second quadrant. And here, tangent is negative. So tangent is negative in the second and fourth quadrant. So the common quadrant will be the second one. Okay, so overall, from here, A is in the second quadrant. So again, you draw first. You draw in the second quadrant. Put in your values. Do your own Pythagoras theorem. Okay, like I mentioned, don't stop here. Write out all the ratio. So write out all the ratio. Okay, remember this is second quadrant. Sign is positive. The rest are all negative. So get all your fraction ready so that you don't make careless mistake later on. So anyway, this is the method mark. Okay, so for the first one, cosine 2a. So in cosine 2a is the troublemaker. There are three formulas. So it doesn't matter which one you choose. Okay, so you got everything already. So for me, I will choose the one that use the given ratio. I prefer to use the given ratio. So I prefer to use a given ratio so that I minimize my chance of careless. So this is a given answer. So given answer should 3/5 is given. So it should be quite safe. So I will get a 7/25. Okay, so but let's say you didn't use this formula. So let's say we try. So let's try cosine 2a equal to cosine square a minus sine square a. So will I still get the same answer? Okay, you will still get the same answer. So you for the three formulas of cosine 2a, you shouldn't be getting a different answer. Okay, now the trick lies with the cosine. The difficult one lies with cosine a/2, which is like the half a. So this is the one we're going to use the star formula. So this is the one that I'm going to use the star formula here, this part. So I am going to use cosine a equal to 2 cosine square a/2 minus 1. So I'm going to use this. Okay, so it will be easier if you let it be k and you use the cosine that you already gotten. And then you do it as if like you are finding k. So you are getting two answers for k. You're getting a positive and a negative answer. So cosine a/2. So you got two possible answers. Don't outright go and reject the negative. So your reject should be based on which quadrant. Okay, so that is the difficult part. Okay, so we do know that A is in the second quadrant. So second quadrant is between 90 to 180. But what about a/2? So you divide by 2, you realize that a/2 is in the first quadrant. So the cosine of a first quadrant should be positive. So you reject positive or negative based on where the angle is. So this part is a bit difficult, and some people will forget about using the star formula. So if the question is asking for sine a/2, so if the question is asking for sine a/2, we will use the other one instead. We will use the cosine a equal to 1 minus 2 sine square a/2. So the question can also ask for tangent a/2. So if the question asks for tangent a/2, there will be some practice that you are asked to do this. So we will be using the other star formula. The technique will still be the same. The one that you're supposed to find, you just assign it as a K. You find yourself forming equation. So that is one difficult part that you actually get used to. So they can ask you for cosine A over 2. They can ask you for sine A over 2. They can ask you for tangent A over 2.